Hello everyone. It's such an honor to be involved in this showcase project. First of all, I would like to briefly introduce about myself. My name is Trung Hieu, and I'm currently working as a lecturer at University of Transport and Communications in Vietnam. I was educated as undergraduate student and master's student in civil engineering at University of Transport and Communications in Vietnam. I got my PhD degree at PhD program for civil engineering, water resources engineering, and infrastructure planning with a major in geoinformatics in Fairchild University in Taiwan. I'm interested in civil engineering field, also time series data analysis and um, geoinformatics technologies and applications, and hopefully we the Asian young scientists can work collectively together through this project, especially in geoscience applications. In this presentation today, I would like to present a case study of the integrating between GIS and remote sensing for evaluating forest canopy density index in Thái Nguyên province in Vietnam. The reason we chose this topic is simply because the forest management becomes an urgent task to maintain and protect the forest ecosystem. In this case study, the forest canopy density (FCD) model is synthesized by the three parameters, including the Advanced Vegetation Index (AVI), the Bare Soil Index (BSI), and Canopy Shadow Index (SI). Also, the Landsat image is processed in ENVI and ArcGIS software to determine the distribution of FCD in the study area. And the FCD map is created as the outcome of this research to assess the forest situation and serve the resource management and environment. The forest canopy cover, also known as a canopy coverage or crown cover, is defined as the proportion of the forest floor covered by the vertical projection of the tree crowns. It has a very important role in ecosystem as it provides structure that affects weather patterns, contributes to nutrient cycling, and also provides habitat for plants and animals, among other things. The study was conducted in Thái Nguyên province, which is located in the northeast region of Vietnam, with the total area of this province is more than 3,000 kilometers square. It includes two cities, one town, and six districts. And the forest in this province has the biggest area in the total natural area. You can see here some examples of some districts in Thái Nguyên province. And the real question here is how we can effectively manage the forest in such the situation of the climate change, and the forest area has been decreasing over the years, not only in Vietnam condition but also globally. This proposed methodology is presented in this flowchart. The satellite image from Landsat 8 was taken in October of the year 2016. It was converted from DN to radians. The Advanced Vegetation Index (AVI), Bare Soil Index (BI), and Canopy Shadow Index (SI) was respectively determined, in which the AVI and BI are used to define the vegetation index, and the scale shadow index was identified from canopy shadow index, and these two indexes in combination with land cover map and field works, the proportion of forest canopy density was identified. Finally, the accuracy assessment was given. Here are some results that we have got so far. The Advanced Vegetation Index is one of the essential parameters to determine the healthy vegetation based on the red and near infrared spectral band. As you can see here, calculated this equation where B5 is near infrared band and B4 is red band. Secondly, the BI is combined from a blue, red near infrared and shortwave infrared spectral bands to capture soil variations. The shortwave infrared and red band are used to quantify the soil mineral composition, while the blue and the near infrared spectral bands has it enhances the presence of vegetation. Thirdly, the VD is carried out by using principal component analysis based on two input parameters AVI and BI, and the value of VD is ranged from 0 to 100%. Next one, the SSI is calculated from canopy shadow index by using a linear transformation. The value of SSI is also scaled from 0 to 100%. SSI by 100% responds with the highest possible shadow, whereas the number 0 respond to the opposite. You see here the result. The next one, the FCD is one of the indexes to identify the forest quality. VD and SSI in our study are combined to calculate the FCD with scale from 0 to 100%. From these above, I mentioned previously, all these indexes were calculations, and from that, the forest canopy density index is identified in the study area. The percentage of canopy density correspond to FCD is also identified, especially as the canopy density is under 15%, it indicates non-forest area. Similarly, for low, medium, and high FCD. Consequently, the area and percentage of FCD classes are identified in which the non-forest area is approximately 88,000 hectares, account for 25%, about 31% correspond to 111 thousand hectares for low FCD, nearly 40% correspond to the medium FCD with the areas equivalent to 141,000 hectares. And finally, the remaining 4% account for more than 14,000 hectares in Taiwan province is for the high FCD. And finally, the glass confusion matrix is performed as presented in this table. It can be seen that most of the FCD is at low and medium class. The result shows that the Gapac coefficient equal to 0.79, the overall accuracy equal to 85.3%, which provides the reliable outcome of this research. And I'm going to finish my presentation here with the conclusion and the future works. Firstly, using GIS and remote sensing data, the achieved results have high reliability based on the physical properties and spectral reflection of the objects on the surface. The remote sensing images can provide useful information in this research. The Landsat 8 satellite data was used to estimate the dense forest variations in the large scale in this study. And as I mentioned previously, the FCD map expressed the forest situation in Taiwan province through the level of canopy density, and most of the FCD is at low and medium class. For the future work, these studies can develop further by using many satellite images in the different period. That may help for assessing the changes of forest canopy density over the time and space. This is one of the important criteria to evaluate the forest quality and contribute to the information for forest management. So my presentation ends here. Thank you so much for your attention, and I wish you all health, happiness, and success. Thank you.